What's up guys, welcome back to another video. So in today's video I'll be showing you guys how you can make your own machine learning project on handwritten digit recognition. So in today's video this is for the first part. I'll be having two parts. So in this part, the first one, I'll be actually creating the model, and in the second part I'll be testing out the model on our own handwritten digits. So this is a pretty easy beginner Python project, so hopefully you guys can follow along, and let's get started. Alright, so I'm going to open up Visual Studio Code. There you go. And so don't mind all of this. This is just old stuff I've been working on, so don't worry about this. Right now we're going to be creating a new file. So I'm going to call this handwritten.py, and let's save it. So I've saved it into a different folder. This is my test folder where I basically do my Python projects. So you can save it anywhere, and don't worry about the rest of this. So basically, before we begin, you have to do a few things. So you can open up your command prompt, or you can do it in VS Code, I think. There are a few things that you guys have to install. So what we're going to do is we're going to write pip install. And so the first thing you have to do is do numpy. That's not how you spell it, numpy, and then hit enter. And so we also have a few other things. So we have opencv-python. We also have matplotlib. It's just mat, so it's matplotlib. There you go. And finally, we also have TensorFlow. And that's all you guys have to do. So you guys hit enter after each one. So those are the 4 things you need to install. So now finally, let's start getting into our code. So we have to actually import these. So first we're going to do import numpy as np. We're also going to do import cv2, which is our opencv-python. We're going to do import matplotlib.pyplot. So we're going to do this as plt. And finally, we're going to import our TensorFlow as tf. And so we're also just going to import os. So let's just do that right now. Import os. So these are all the things we need to import. So numpy is basically, we're going to use this for numpy arrays. cv2 is computer vision. That's what cv stands for. So it's going to help us load our images that we're eventually going to use to test and process those images. Now we use matplotlib for visualization, but you don't really need it, but I recommend, if you guys are following along with the tutorial, that you guys use this. And finally, we use TensorFlow for the actual machine learning part. So let's get started. And so the first thing we're going to do is load our data. So we're going to do mnist equals tf.keras.datasets.mnist. So basically what this line does is we're going to be loading a data set from TensorFlow. So TensorFlow has this huge library or data set of handwritten digits. So that's basically what we're going to be using for this project. So TensorFlow just makes this a whole lot easier. Now TensorFlow also helps us with the actual machine learning part, which I'll show you guys later. So now normally when we're doing machine learning, we have a training data and we have test data. So we usually have to make a split, but TensorFlow already has it ready for us, training and test data, so we can just call that in. So in here we're going to put in our Xtrain and Ytrain, and then we're also going to pass our xtest and ytest, and then we're going to say equals mnist.load data. So basically what we're doing here, and so we have an x and y. So what x is our actual image, and then y is just the label, the classification. So if the image is 7, the y will just say 7, like we know what it is. So we have a separate training data and separate test data, and so we're just calling that in here. So the next step is using our normalizing function. So basically what this does is it puts our pixel value anywhere from 0 to 1. So let's say we have a strength from 0 to 100, and so let's say that strength is 64. So now what the normalizing function will do is it'll put it at 0.64, which is a value between 0 and 1, but it's still relative to what the actual value is. So to do this, we're going to be using our x data because that's the actual image. So we're going to do xtrain equals tf.keras.utils.normalize, and then we're actually normalizing our actual Xtrain, so we just need to do pass in our Xtrain, and then we're going to also provide our axes, which is 1. So now we do the same thing for our X test. So we pass in X test, and then here we just change it to X test. That's it. So now it's time to finally create the actual model. So what we're gonna do is we're gonna say let's call it digit model equals. So we're gonna do tf.keras.model.sequential. I spelled that wrong. Sequential. And there you go. So now sequential is basically just like a very basic neural network form. The next step is adding layers to our model. So what we're gonna do is, to do that, we're gonna do digit model dot add, and then in here we're gonna pass tf.keras.layers. And so the first layer we're gonna do is a flatten layer. Our image is basically a 28 by 28 pixel image, and so the flatten layer will basically take those 28 pixels from a grid-like form and we'll put it into a single big line of 728 pixels, since we have 28 times 28 pixels, so a total of 728 pixels, I think, will be in one big line instead of a grid-like form. And never mind, it's 784 pixels. That's the correct answer. So anyways, in flatten, we're gonna pass in our input shape. So we're gonna do input shape equals, and then in here we're gonna do 28 by 28, since that's what each of our actual image of our number is, 28 by 28 pixels. So after a flatten layer, you want to have you want to put a dense layer. So we're going to put our dense layer, which is basically, so here let's just do the beginning part, digit underscore model dot add, and then tf dot keras dot layers dot dense. So our dense layer is just a very simple layer, and so in here we're going to pass how many units. So we're going to put 128, and now we have to put in our activation. So our activation, we could do it as a string. So that's what we're gonna do. We're gonna put in ReLU, which stands for rectified linear unit. You guys can search it up. It's basically like, if it's negative, it'll be at 0, and then it goes up linearly. So now we're just gonna have another one of this layer the exact same way, and then we're gonna put one more, but this time we're denting it. We're putting in 10 units. Now what we're doing is we have 10 neurons, and so each of this each stand for a number 0 through 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is the number classification. So let's say the third neuron is firing up, which is, it thinks that the third neuron is the correct answer. That means 0, 1, 2, it thinks that 2 is the correct answer to what's on the screen. So something we also have to do is change this to softmax. And this, what it does is, it's kind of like a confidence. So each of the 10 neurons will have a number. They will all add up to 1, which we can interpret as 100%. So it will have a confidence. So let's say the number 2, or the third neuron, is at 0.96 for softmax. It puts it at that confidence, let's say. So that basically means like 96% it thinks that number is correct, and the rest of them will also just make it so that they add up to 1 or 100%. So we can say the softmax function is like a confidence. So now while we're done with this, we just have to compile our model. So we do digit model equals, not equals, I mean dot compile. And so in here we're gonna pass our optimizer, which equals atom. We're also going to pass our loss, which we're gonna have as sparse categorical cross entropy. So I hope I'm spelling all this right. We'll eventually see if I get an error. And then also we're gonna pass in our metrics. So for our metrics, metrics, we're gonna have here we're gonna pass in accuracy. So that's it for compile. Now we have to do a fit, which is basically our train. So we're gonna do digit model.fit, and so here we're gonna pass in our Xtrain and then Ytrain, and then here we also give epochs. So what epochs will be is the number of times we'll have our project run. So let's say we pass in 3, so it'll run over that same data 3 times to make sure that it has the best, the lowest loss or the best accuracy, because that's what we're trying to get. So obviously we can't have like 100% accuracy. That would take way too many epochs. That would be actually infinite, because you can never get 100%. So let's say we're going to pass in 6 epochs. So we're going to have this run over the same data 6 times. So now, while we've done all that, we've basically created our neural network model, and the last step is to finally save this model. So we're going to do digit model dot save, and then let's pass in a name. So let's do handwritten dot keras. So it has to be dot keras. That, or I was getting a problem before when it wasn't dot keras. So just make sure that you have the name and then dot keras. So this is it for the first part. The second part, we'll use this model and we'll test it out on our own handwritten digits. I'll show you guys how to do that in the second part. So now let's run this first part. So I'm going to do Control S to save it. And finally, let's run it. So let's see how this works out. So there are some things that TensorFlow has to run before it runs our program. So don't worry about any of this. This is completely normal. Just wait. You'll eventually see your outcome. Okay, so I got an error. Let's see what the error is. Alright, I found the error. So I put model instead of models. So I don't know why it's not showing up like the suggestions or whatever. So I have to like write everything by hand. So it's supposed to be models. That's the one thing I messed up. Just make sure you guys change that, and let's rerun it. Alright, I just noticed I spelled activation wrong, so I'm just gonna fix that. Activation. There you go. So activation. So this is really annoying, but make sure you guys do it correctly when you guys are doing it. Alright, so I just hit run and I'm waiting for the outcome. I hope. So it's running. So now I fixed all the problems. So as you can see, epoch 1 out of 6. So as you can see, it's running 18,075 each epoch. So we're gonna have it trained for 6 epochs. Here you can see our loss and our accuracy. So let's just look at our accuracy. The first time it's 86. And now it's already jumped up to the 90s. So this is looking really good. It's only number 2 out of 6. So I'll be back once it goes to number 6. You guys will also notice each time it runs a little faster than the previous time, because it's already gone through the data. So it knows a little bit more. So that's why we also have our test data, to make sure that it can perform correctly against data it's never seen before. Alright, and we are on the last epoch. So it seems to be performing pretty nice. We're at 99% accuracy. Hopefully it'll stay at 99 and not go to 98, but let's see. And it seems to have stopped at 99 accuracy, so that's pretty good for our model. So if you will look up here, our model has also saved as handwritten.keras. So wherever you guys do this in your whatever folder, or if you do on desktop, it will also save the model. So make sure you guys save this model for part 2, since this is going to be important for testing our own data using this model. So hopefully you guys enjoyed this video and learned something new, and I'll see you guys in another video. Bye!